Thanks for coming. So my name is Jinqing. I'm working ThunderCore engineer. Today I will give a talk about the ThunderCore, our blockchain. So I assume some people already heard of us and even played with us. And for this talk, I just want to give people some brief introduction about technology and understand what we're building and how we build it, how it works, and give people some details about ThunderCore blockchain under the hood. So very quick recap, what we are building. So ThunderCore is a general purpose public chain, and it's has very high throughput. Right now, we already launched on mainnet. It achieves 1200 TPS, and if you already played with us, do some of the transactions, you can see the confirmation about 1 to 2 seconds for one transaction. And it's fully compatible with EVM. Any EVM Serum smart contract, dApps can migrate to our chain in minutes. It's scalable. It supports high throughput without failure. And thanks for our co-founder, Professor Yilenshi, just assisted there, is all the work has been mathematically proved to secure. So that's what ThunderCore is. Okay, so maybe people will ask, why ThunderCore so fast? And how does we achieve decentralization from the ThunderCore? So I hope after this briefing talk, you can find the answers. I hope you can understand how it works. Before we dive into details about how ThunderCore works, we can do a quick recap of some of the traditional proof-of-work blockchain works. So basically, we know that, for example, for Ethereum, there are a huge number of nodes distributed all over the world, and they're connected by a P2P network. If you want to submit a transaction, play a game, or send tokens to a friend, you submit one transaction to one of the nodes in the network. And given the honest host nodes agree on the logs, we achieve the consistency. And the transaction can incorporate soon, and we achieve the liveness. Then eventually, we got this chain was built up. So, however, because it's a P2P network, it has very limited bandwidth. Even some protocols like Nakamona, cannot fully leverage the network bandwidth. Such a bandwidth issue and introduce a longer latency for our transactions. And we can see how low the throughput of the network and how long of latency. And we may rethink about the messaging model of this blockchain network and to improve the scalability and rethink about incentives and economics based on maybe POS. So here is our answer, Thunderella paradigm. That's a protocol suite named after Thunderella. Actually, the Thunder is also the prefix of Thunder. That's how our company's name comes from, ThunderCore or Thunder token, something like that. Okay, in our network, we also have some full node, just like Ethereum. We have accelerator, and one or more than one accelerator in our network, and multiple from tens to hundreds of committees of validators. That's the architecture of Thunderella or ThunderCore network. If you want to send a message or you want to submit a transaction, definitely you still need to send it to our full node. Then the first step we call the propose. The accelerator will receive all the transactions which are relayed by the full node. It just insert this transaction in one block, build a block, and sign it, use the BLS key, and we call this propose, and send this first block. It has not been confirmed, send it to all the validators. And all the validators will validate, or the committee members will validate the transactions to see if they're legitimate or valid. If everything is fine, they will sign this proposed block individually using their BLS key and send it back to the accelerator. This step we call the vote. Suppose accelerator receive more than 3/4 of a vote. The model think this block contains all the validate transactions, and we will finalize the block, and we call this step is the notarization, and the blocks will be inserted on the chain. So you can see this is a single round of the vote, and that's a basic way. And it's a hub-spoke network architecture rather than a P2P network. That's a basic way how we achieve the fast or high throughput and achieve 1200 TPS in our mainnet. And actually, this is already conservative number. In our test environment, it's easy to achieve 2000 or even more. But to guarantee reliability in our mainnet, we just guarantee 1200 TPS for mainnet. That's basically how we generate blocks, how we build the chain. So maybe next question is, okay, who dominates the whole process? How do we guarantee the consensus? The consistency? So I want to notify one thing here. Accelerator here, he does not vote. He is just the coordinate. The committees has a power to vote or to make the consensus on the blocks. So basically, the first layer of the decentralization of our system relies on the committees. As I mentioned, we can have tens or scale up to 100 of the committees. And they could be everybody. Everybody who holds a standard token can be a committee member through the bidding and the rewarding process. Suppose you hold a Thunder token, you can send a bidding message to our full node, say, hey, I wanted to be a committee, but you need to stake in your tokens. I want to put 10,000 or 1 million tokens to be a committee. And we will run the bidding, the whole network will run the bidding protocol based on the tokens you have staked in or some other variables to determine who could be the committee for the next round. After each committee member, they vote on each block, they will earn the credits based on the transaction fees. The more you vote and the more tokens you stake in, the more rewards you will receiving. That's a basic idea about how anybody can be a committee member and to get rewarding from the whole system. Okay, then that's how the thing works. Maybe the next question is, this blockchain, ThunderCore blockchain, achieved 1200 TPS. We call it a faster pass. Then the next question is, how do we know the faster pass working properly? And we have basically two mechanisms to guarantee everything is fine. First one is a live message. A live message actually sent by the accelerator. So this is just a snapshot for series of blocks on our fast pass. It's a hash of a series of blocks, and it will be posted on another chain we call the slow chain, which is well known to everybody, looks like a ground truth. So far we choose Ethereum as our slow chain. So if the fast pass goes well, if the accelerator is not crashed, if the committees, more than 3/4 of the committee is still working, everybody should see the live message on the slow chain periodically. If the live message is missed, that means something wrong with our fast pass. In the meanwhile, if you submit your transaction, what if the accelerator or the committee members never vote on your transactions, or something censorship happened, or something wrong? So if you're a client, you can send a yield message also to the slow chain. That means the yield message actually is a wrapped transaction you intended to submit to our fast pass. You just say, hey, why do you guys do not process my transaction? Here's my transaction. You do not show up on the fast pass. Right now, I submit to the slow chain. That's Ethereum. You cannot manipulate. Everybody should see it. So the yield message, which will be eventually put on the slow chain, will be monitored by everybody, including full node, including committee. So after the yield message is on the slow chain, it should be processed sometime later. If the other nodes, including committee, we assume most of them honest, they cannot see the yield message or the transactions are processed, they will stop work. They will think something's wrong with the accelerator or, oops, sorry. Oops. Okay. So they will see something wrong with the fast pass. And all the accelerator is doing some censorship or the dishonest things. If either one of the things happen, we call it a fallback rule to happen. So most transactions or most behavior will fall back to the slow chain. So we need to do another recover work to either find a new committee or find a new accelerator to recover the fast pass. That's how we handle decentralization. First of all, everybody could be a committee member through the bidding process. Secondly, if you're worrying about the accelerator, we could have multiple, and we have this fallback recovery mechanism to guarantee the accelerator or the whole network can do something wrong, because we are waiting for the live message on the slow chain to guarantee the network is working, to guarantee the liveness. And also, we have the yield message to guarantee your single transaction should be considered equally with others, if this one should be processed. So that's how we achieve decentralization based on using the fallback recovery mechanism between the fast pass and the slow chain. Okay, quick recap for Thunderella in 2 sentences. First of all, we have a single round of voting. That's the way we achieve high throughput when things are good. And when things go back, we will use a slow chain for fallback. Again, in this case, is a Serum. That's a ground truth. That's a backup plan for ThunderCore as well as Thunderella. However, the reality is not that amazing. Fallback is always a cost, and we did some experiment. The accelerator switch takes about 10 minutes, and in some worst case, even slower. Think about that. All the recovery should happen on the slow chain, and the usually slow chain is really slow. If I'm the user of the ThunderCore, if the fallback recovery happens, I will see a long latency of everything, because nothing good has happened. That's something really painful for our users. So, back to October, last year, October, Elaine and our research team have a new development of the Thunderella paradigm. Then we have another protocol called the Pili and the Pala, especially Pala. So that's a new fast pass consensus. So basic idea that previously, maybe on the fast pass, there's only one accelerator. But actually, we can support multiple accelerators on the fast pass. And we can do agile rotation or election on the fast pass for the accelerator as well. So think about that. Previously, we only elect committees, and we did not talk about accelerator. We think accelerator is neutral. We only have something to monitor the accelerator. We did not talk who could be an accelerator. But in Pala, everybody can be not only a committee, also could have a chance to be accelerator. And you could be a backup for the next accelerator. And we do the accelerator election on the fast pass as well. So that means if fallback something happen, or something wrong with accelerator happen, we do not have to fall back to slow chain. We can do the recovery on the fast pass as long as the committees, most of the committees still survive. That saves a lot of time, a lot of the latency for our users and for our system. And we have something more enhancement. Recap, if there's only one accelerator can propose the blocks. That means we only have one pipe. If we have multiple, we actually can do something in pipeline. That not only improves the latency for the fallback recovery, also could be opportunity to improve the throughput of the whole system, of the whole network. That's we call Pala. And we already have open source of Pala. So then another question, if we have Pala, do we still need slow chain? Do we still need a slow chain? Because you think about that, if you need a slow chain, you need to take care of 2 systems. That makes implementation really complicated. And slow chain is a backup plan. Honestly, we do not want to touch it, because that means something wrong happened, and that means a bad user experience. So another benefit of Pala that it can help us to do the decentralized monitor on the fast pass only, just like accelerator rotation. And also, we may still need it, but need the slowjam only at the very extraordinary circumstances. For example, the entire committee corrupted. That means the accelerator election cannot happen, or some basic functions cannot be performed on the fast pass. That's the only worst case. So basically, we may still need a slowjam, but the Pala makes things simpler. We stay on the fast pass for most of the time, and most operation, including the accelerator rotation, will happen on fast pass only, and also improve the throughput of the whole system. Okay, above that's just basically how ThunderCore works, with the ThunderCore under the ThunderCore and the ThunderCore with the Pala. So we already did a lot, we already achieved a lot of something, and I would announce here for everybody. First of all, open source plan. So we already open source Pala consensus POC this Wednesday, I remember. Yes. So everybody can access our Pala POC code from the GitHub. And we are approaching to the ThunderCore full node open source in Q2 2019, hopefully by the end of June, if not in July. So we are testing. Actually, I was looking at the bug fixing reports yesterday. A lot of funny things happened for full node stuff. And besides that, after we open source full node, we will have a plan to welcome everybody to run the full node, ThunderCore full node on your machine. And I heard from the product manager, so at the beginning, we will at least support 100 external full node all over the world. And we will release more information and tell people the exact program for that. And after open source full node, we also go ahead and open source committee and accelerator code. And we will see our migration from ThunderCore to Pala in our open source program. You will see our POC, Pala POC stuff will eventually migrate to our product code, hopefully by the end of this year. That's informal, unofficial announcement. Sorry. Also, we are calling for external committee. As I mentioned, everybody could be a committee. Definitely, if you have more tokens, you have high probability to be a committee. For those guys who has less token, but you still want to benefit from the external committee rewarding, we have another program I will follow just after these slides. So we already planned a call for external committee program, and if you pay attention to our blog on media, we already reserve seats for different people. 25 reserved seats for nonprofit organizations, maybe investors, or maybe even universities. 25 seats for staking pool service. Those for the retail investors or the people with a small amount of tokens. We also reserve 50% of the seats for open bidding for everybody. You can just try to it. And we want this incentive mechanism to encourage honest participants and the high performance participations. Why high performance? Why high performance? Think about that. Our accelerator waiting committee to vote. Latency, computation, all those stuff. If the votes come very late, it will just downgrade our throughput. So we're actually looking for honest and high performance participants in the meantime. So that's some challenge for us. Let's see what we can achieve. Okay, staking pool service. If you have tokens, you can earn more tokens through this program. No matter, we will run some committee seats on top of this staking pool service. You may not occupy a single seat, but you may share the seat with some other people. And you can earn a transaction fee, and you can also, we also set up a 100 million Thunder token for the rewards. And at most, if you staking your tokens for 1 year, you can get the 30% APY from this pool. And I think this one will be launched very soon, in a couple of days. As I heard, well, we are already done all the testing. It's just in the internal beta test right now. Hopefully you can see it maybe on Monday. We also are working on the cross-chain asset. So we know Ethereum is a very, very fantastic ecosystem. Programming languages, applications, and its own ecosystem, some of the non-fungible tokens and the stable coins, and a lot of digital assets also survive together with Ethereum. We want to leverage and support this ecosystem. So as I mentioned in the second slide, ThunderCore is Ethereum compatible since day one. And technologically, we're superior to the Ethereum. And we want to give Ethereum community better user experience since we are more scalable and can provide a high throughput. We want to support all the digital sets on the Ethereum and give the users, developers, an opportunity to import or export access to ThunderCore, like Ether, like ERC20 tokens, and non-fungible tokens, and other stable coins. So this one is already on the engineering plan, so we will see the details very soon. Okay, this may be good for developers and the fans of the Thunder. We already launched the Ambassador program. Ambassador program is the program we try to attract the technical talents and join us as a community. So he will stands for Thunder to the local community all over the world. All over the world. So you can see the details from this blog, provided link here. And we already got some applications, and we already have 80 university ambassadors will join us, maybe students, fans, or even professors. And we want to bring the awareness of the ThunderCore to campus and promote ThunderCore through this ambassador program. Okay, again, so thank you everybody for coming. So here's the basic timeline. So about the company. So we have the US office opened on February 2018. And in July, we have the Taiwan office, but actually also July last year, we launched our testnet. And then in the Q1 2019, we launched our mainnet. So it's already there for almost 3 months. And you can see it's grown very fast. We already have huge amounts of the DAU and some stuff. Sorry, I don't remember exactly numbers. 11,000 DAU, okay. And we welcome everybody to come to play with us, deploy our dApps, and we will have workshop maybe today, right? We have another workshop, right? Okay, sorry. So, and we will also in another workshop like a travel in this year, and welcome everybody to come with us and to come to play with us. And one more thing I want to emphasize, we are purely compatible with Ethereum. Any Ethereum compatible program or the app can migrate to ThunderCore in minutes. All the Ethereum existing developer tools, like a Truffle, like Remix, can integrate with our chain almost without any change. You just need to change your RPC URL directed to our ThunderCore stuff. Then it's done. So that's something we are proud of. We give the most convenience to our developers and our users. Besides that, you will see more program for the developers. We try to bring users to developers and help to build the bridge between the users and the developer. Not only the cryptocurrency geeks or fans, but also regular users. Actually, just a couple days ago, our CEO, Chris Wang, gave a talk on the consensus. Right now, we are specifically talking to the gamer players, regular game players, not only cryptocurrency, crypto game players. We want to bring more and more people onto our chain, as well as to the blockchain community, and bring more opportunity to developers to enlarge their user space of their applications. Okay, that's all my talk. We still have 2 minutes for questions. Go ahead.
So I guess 2 questions regarding the accelerator.
Mm-hmm.
The first one, you may have mentioned this, but I might have missed it, is what's the incentive for someone to run an accelerator? And second, what's to stop an accelerator from censoring some of the validators that go through it so that it can possibly change the outcome of a vote? Like, it looks like from the diagram that the validators are routed through the accelerator. So if
The committee.
the
Committee, yes, committee.
The committee gets routed through the accelerator.
Yes.
What's to stop the accelerator from censoring certain committee members? So I guess those are the two questions I have about the accelerator.
Okay, so first one, because accelerator plays a key role here, although it does not vote, but it's collect transaction and propose blocks. It needs very large resource to do it. If it's a very weak one, definitely will downgrade the process. So the benefits or the incentive for the accelerator bidders or the participants that it can take more percentage of the transaction fees from the block. That's the basic way. How we incentivize people to participate in as an accelerator. He has another question. Okay. The second one, so you mean the censorship, right? The censorship one that, okay, so if the censorship of the traditional, the regular transactions, we have yield message. We have yield message. If your transaction never seen being processed, you put your yield message on the slow chain. So everybody can see your yield message, including the committee. The committee also monitor the yield message on the slow chain. Then it will wait for accelerator. If accelerator is still honest or no censorship, he may miss this transaction for whatever reasons. But it also need to monitor the slow chain. If it detects a yield message on the slow chain, it will pick it up and check if it's already processed or not. If not, it will put in the next block immediately. And the committees should wait for these transactions for the next proposed block. If, let's say, for a long time, the yield message is still not processed, that means a warning. The accelerator doing something wrong. Maybe do some censorship. The committee, if the committee realizes that, it can stop working. Okay, I do not trust this accelerator, something wrong. They stop voting, that means a live message will not be generated because the live message is a snapshot of a series blocks.
Sorry guys, you gotta wrap it up.
Okay.
Thank you.
Thank you.